Computer Aided Engineering Graphics course. This is Upender, working as an assistant professor in the Department of Civil Engineering in Andhra Engineering College. Today I would like to explain about isometric projections from this course. What is meant by the isometric projections? Isometric projections or isometric view is nothing but the three-dimensional view. It is the pictorial view of the object. It is used to create the pictorial drawing or pictorial view of the object. Isometric projection is nothing but the conversion of the orthographic projections into the isometric. It means the entire object is seen in a single view. Let us know more about the isometric projections. It is used to create the pictorial drawing of an object. It is defined as a single view parallel projections obtained by keeping the object. So here projection or projectors is nothing but the eyesight or the eye rays to see the object. When I see the object, for example, this is the mobile. My eyesight means my eyesight to touch this end and to touch this end at a time. Clear? The entire object, it means the four sides of the object. The eyesight means the four parallel projections or projectors at a time to see the object. It is means orthographic object. Here the orthographic object is converted into the isometric. It means the 30 degrees inclination. If the object is keeping 30 degrees inclination to the axis, the entire object length and width and thickness is now visible. That is called as isometric view. It is defined as a single view parallel projection obtained by keeping the object in such a position that all the three mutual perpendicular geometrical axes are equally inclined to the plane of projection. The projectors follows the rules of the orthographic projections, that projectors are parallel to each other and perpendicular to the plane of projections. Here all the projectors are the parallel to each other and perpendicular to the plane of projections. A multi-view drawing requires two or the more orthographic projections to define the exact shape of the three-dimensional object. It means orthographic projections require two or three to define the exact shape of the three-dimensional object. It means the orthographic projections. Here the mobile is the orthographic projections of it is a two-dimension. Here it represents the length and width. It means two or the more orthographic projections to define the exact shape of the three-dimensional object. It means at least require two or more than two orthographic projections to define the exact shape of the three-dimensional object. Each orthographic view is two-dimensional drawing showing only two out of three dimensions of a object. Let us know more about the isometric projections. Introduction to the isometric projections. Consequently, no single view contains sufficient information to completely define the shape of the object. All orthographic views must be correlated together to interpret the object. These views can only be corrected, interpreted and visualized by those persons who have the good knowledge of the principles of projections and a great practice to read multi-views to interpret the actual shape Thus it is necessary to draw a pictorial view of one kind or the others, so as to enable a common man to understand. The isometric projection is the most popular as it provides the overall view of an object at the first sight. So that's why the isometric projection is most popular. Let us know more about the isometric projections and isometric view. In an isometric projections, a scale factor of 0.82 or 0.816 is used to prepare the drawing, whereas in the isometric view the true length is used. If in case the problem to find out the true length of the isometric projections, this scale factor is helpful for the preparation of the true length of the isometric view of the object. The normal length into 0.82 scale factor to calculate the actual true length of the object is obtained with the help of this following scale factor. Thus the isometric view of the object is larger than the isometric projections because of easy of the constructions and advantages of measuring the dimensions directly from the drawing. It is became a general practice to use the true length instead of isometric lengths. Let us know more about from this figure from A and B. So the orthographic views of the cuboid, figure B shows it is geometrical projections, whereas the figure C, it is the isometric view of the figure C shows it the isometric view. Thus the isometric projections looks smaller in size than the isometric view. It may be noted that if it is desired to draw the isometric view of an object containing some spherical features, it is general practice to draw the isometric projections only. For example, it is the orthographic projection. Here one and another view of the orthographic projections. Orthographic projections only the length and width or length and height. Here it represents the width and height, here thickness and width of the object. So these two drawings combines to form the isometric view or the isometric projections of the object is figure B. For example, here width, thickness and height. These two combinedly view, these are the two separate orthographic projections. These two orthographic projections combinedly view is possible in the isometric projections or the isometric view. It means the object is viewed in a single view is possible in the isometric view. It is the three-dimensional object, it is the two-dimensional, and it is also two-dimensional object. These two are the orthographic projections and this is the isometric projection. For example, draw the isometric view of a square of side 40 mm, keep it kept in the vertical positions and horizontal positions. It means horizontal positions means take a reference line and put the both sides is 30 degrees, and vertical positions in the taken one point to the reference plane, and one side is the 90 degrees and another side is the 30 degrees position. So it represents the vertical positions and both sides take a reference point to take the 30 degrees on the both sides of the plane is called as the horizontal positions. And here conditions is when the square is kept vertical, and draw a 40 mm long vertical line of AD, draw another 40 mm long line AB inclined at 30 degrees to the horizontal. It represents it means the horizontal view. It means draw a 40 mm long line AB inclined at 30 degrees to the horizontal, complete the rhombus ABCD which is required isometric view. And second one is the horizontal positions. Draw the 40 mm long line AD and AB. Sorry, it is the vertical position represents, it is the horizontal positions, each inclined at 30 degrees to the horizontal such that included angle between them is 120 degrees. Join ABCD to represents the isometric view of the square. For example, this is the orthographic projections of the square. Each side is the 40 mm and this is represents the vertical view of the object, and this one is the horizontal view of the object. For example, take a reference line. First of all, I am drawing here horizontal position of the square. Horizontal position of the square. This is one square object. It is the orthographic view of the 40 mm is the each side of the square. Each side of the square. First of all, here I am taking reference line, XY line, reference line. Here put a 30 degrees to the each and every side. For example, this point is A, B, C and D. Here I am taking A point. Here I am taking A point to the 30 degrees inclination to the reference line. 30 degrees inclination to the reference line. For example, this is 40 mm line of the A, B. This portion is completed, and then go to this position A and D. Here I am drawing A and D position with 30 degrees to the reference line. We are also same, taking 30 degrees reference line. Also 30 degrees line, and this line is the 90 degrees and this line is the 90 degrees line. Or to take a radius from B to C and D to C, to take the radius of B to C and D to C, to mark this radius with the help of the compass to obtain this point, C point. For example, this is point A. Okay. This is 30 degrees and 30 degrees. This is the horizontal view of the square, and next vertical view of the square. Vertical view of the square. One side is the 90 degrees and another side is the 30 degrees. It is the 90 degrees with 40 mm line, and draw the another line of the 30 degrees to the reference line. 30 degrees to the reference line. And here drafter is fix the drafter, one edge is parallel to this line, and to draw the 40 mm line at this point. With the help of the ruling ruler of the drawing instrument, we should to draw the parallel line of this line, and this line to draw the parallel line from here with the help of the ruling ruler to take the reference, this A and D, and this parallel line drawn start from here. This is the end point. This is the vertical view and this is the horizontal view of the square. This is the orthographic view, this is the isometric projections of the horizontal view and vertical view. To take the another example problem, draw the isometric view of the cylinder of the base diameter 50 mm and 60 mm. The axis of the cylinder is perpendicular to the horizontal plane and vertical plane. Here the cylinder of the base is perpendicular to the horizontal plane and vertical plane. And the diameter is the 50 mm, axis is the 60 mm. First of all, to draw the rhombus of ABCD of the side 50 mm means to draw the rhombus of the ABCD of side of 50 mm, and in case AB and BC are inclined at 30 degrees to the horizontal, whereas in case AB is inclined at 30 degrees to the horizontal and AD is vertical, inscribe ellipse in a rhombus ABCD using the 4-center method. 4-center method reference is used to draw the rhombus of ABCD inside the rhombus of ABCD. Draw the 60 mm long line of the BB1, EE1, DD1 and FF1 along the isometric axis as shown. Draw the another ellipse 4-center method where the center points are B1, E1, D1 and F1. Draw the tangents to connect both the ellipse. Here is the inner half of the ellipse. In case to obtain the required isometric views. It means first of all to draw the A, B, C, D with the 30 degrees to the reference plane of the AB and BC, or the 30 degrees to the reference plane, and to mark the D point from the A to B and B to C radius to cut the arc to obtain the D point. Then take the shortest distance. Here the shortest distance is BD. AC is the longest distance, longest side, or BD is the shortest side, and to connect to mark the PQ or S points with the help of this distance from the B to C to mark the P point, and from C to D to mark the another point of the Q, and to D to A is the R and A to B is the S. And these points P, R and Q connect with the B point. These two are the opposite points of the B point, and S point and P points are the opposite points of the D point. To connect all these points and to intersection lines are marked as the E and F. To take the 60 mm reference line from center, and to take the reference line from the E, F and another line from the D and B. To connect all these lines with the help of the radius of the B to R and D to S. To draw the ellipse, and to connect the remaining portions with the help of the E as the center and F as the centers to complete the remaining portions of the ellipse with the help of the E and F as the centers. And this is the vertical positions of this cylinder, this is the horizontal positions of the cylinder. These two positions to represent the isometric view of the object. It means it is vertical projections of the object, horizontal projections of the object, because both sides is 30 degrees and this is the vertical positions of the object. It means the 90 degrees and the 30 degrees. Thank you.